Students, we are given this differential equation y dash is equal to sine squared of x negative y positive z. We are expected to solve this. So foremost, what I'm going to do is I'm going to take x negative y positive 1 to be equal to z, and then I would be differentiating with respect to x. So this would give me 1 negative differential of y with reference to x would give me dy over dx positive 0 is equal to dz over dx. This can be rewritten as 1 negative dy over dx is equal to dz over dx. I need dy over dx, so I will move dz over dx and then I would move out dy over dx. So this is the substitution that I would be using. Now we are given that y dash, which is dy over dx, to be equal to sine squared of x negative y positive 1. Okay, but since I've taken x negative y positive 1 to be a z, this is going to be sine squared of z. Dy over dx is going to be 1 negative dz over dx. So if I were to rewrite this, I can rewrite this in the following fashion by moving sine squared z to the left, so that would give me 1 negative sine squared z, and moving dz over dx to the right, so that's going to be dz over dx on the right. Now since 1 negative cos squared theta is sine squared theta and 1 negative sine squared theta is equal to cos squared theta, we know this formula. Now because of this formula, instead of 1 negative sine squared z, I'm going to use cos squared z. So that is going to be dz over dx. So I can move this up and move cos squared z down. So this is going to be dx is equal to dz divided by cos squared z. Now since 1 over cos squared x is equal to secant squared x, this is going to be dx is equal to dz. So I can rewrite this as secant squared z times dz. Now integrating both sides, you need to write this statement. Integrating both sides, we get, so what do we get? Integral dx is equal to integral secant squared z times dz. Integral of dx is x. Integral of secant squared z is going to be tan z. Okay, of course you have to have a positive constancy. Now I would be rewriting this as tan z is equal to x. Definitely you can place the arbitrary constant c over here, but in fact you know that z is equal to x negative y positive 1. So this implies tan z is going to be tan of x negative y positive 1 is equal to x positive constant c. So this is the solution